the trick with these is that sometimes the calculator is misleading, okay? We did the notes on 1B. We talked about the monomial functions and even and odd symmetry, and then we talked about an even power with a positive or negative coefficient means the ends are going the same direction. An odd power with positive or negative coefficient means the ends are going opposite directions. Okay, this is what you were supposed to do this weekend. Last time I was in Delta Math, it wasn't looking too good, so please make sure you have those two things finished up. Now we're on to 2A. So we should be able to predict this. Does anybody know what this is going to look like? A 3x to the 6th? Just like a parabola, right? Remember how I did a to the 4th on the notes? And it was just a parabola. So I typed 3x to the 6th. And this is what I got. I'm just trying to save us some time here. So it almost looks horizontal down here at the bottom, but it is not. If you scroll along there, it is increasing or decreasing depending on which side of 0 you're on. It's not constant. Okay. What is the domain here? This is the confusion, students. I highlighted this because I was worried about the domain. Do you understand that this is getting wider and wider eventually? Okay. You can also just look at this. Remember, domain is what you can put in for x, and you can put anything in there you want, right? So domain is all real numbers, or you can write negative infinity to infinity. But range, can anybody tell me bottom to top what's happening? What's the lowest this goes for y values? Yes. So this is 0 to infinity. We could graph a couple ordered pairs. Well, that's not right. Erase that. If you put a 1 in here, 3 times 1 to the 6th would still be 3. The same with -1. Okay, I don't think we can go beyond that, because anything beyond that, if you put a 2 in there, 2 to the 6th is really big, and then you multiply it by 3 and it's really bigger. All right, it does have an x and y intercept at 0, 0. Okay, guys, do you remember how this works? Increasing interval are x values, domain values, where it is going up from left to right. Anybody tell me which area that is? One of these isn't here. Do you want me to hang on to it, or you want? Yeah. Okay. Anybody? Which side is it increasing on? Left side or right side? Yeah. This side is going up. So we say from 0 to infinity, 0 to the right. Okay. It is decreasing as we trace it left to right on the left. Okay. And to say left, you say from negative infinity until 0. Because again, it's x values. I know it seems weird because you want to say, wait, it's going up towards infinity. But remember, as you go left to right, it is decreasing as you come from the left until you hit x value of 0. It has symmetry with the y-axis. So it is an even function. It has no discontinuities. And the end behavior, guys, is, can I just use y is going up on both ends, right? As x goes left or as x goes right. Honestly, this is your notes. If you want to just write down there both ends up, I'm fine. you know what I'm saying? If you don't want to write all that funky notation, it's okay. As long as you know how to do the funky notation on a test or quiz. All right. Now the next one is an odd power. So remember, a cubic was doing this shape. Well, this one has a negative 2x to the 5th. So it's like reflected, it's going this way. Here's my graph from my calculator, negative 2x to the 5th. If you put a negative 1 in there, it would come out positive 2. If you put a positive 1 in there, it would come out negative 2. If you put a 0 in, it come out 0. So it's like this. It is pretty skinny because if you put a 2 in there, you'd have like negative 64. So it's going down really fast. According to their graph, it should be a little flatter across here, but it's not a big deal. All right, who can help me quick? Domain, anybody? Yep, all real numbers, range. All real numbers, it goes through 0, 0. Okay, what about increasing or decreasing? As you trace it left to right, what are you doing the whole time? Yeah, if I start here and I trace this way, the whole thing is decreasing. From the left to the right. Okay, at no point is it increasing, so you can write none or leave it blank. Symmetry, anybody know what kind of symmetry this has, if any? It has origin symmetry, which makes it an odd function. It has no discontinuities, and the end behavior, let's see, it is up on the left, but down on the right. I don't really think that one's too confusing, a little misleading in that it doesn't seem to be getting wider and wider, but it is. It's just doing it very slowly. Everybody think they could get those two on the calculator and be okay with filling those in? Okay. A rational function can be written with a negative exponent. Do you remember negative exponents, guys? Negative exponent means you have to cross the line. It's on the wrong side of the fraction bar. So an x to the negative 1 is also written as 1 over x. It's called a rational function. Power functions with negative exponents are undefined when x equals 0. Therefore, they will contain discontinuities. Okay? Because the denominator has an x cannot be 0, and so it has a vertical asymptote. That will also mean it has a horizontal asymptote, because if you can't get it, put a 0 in, you can't get a 0 out on one of these. Okay, so x equals 0 is a vertical asymptote, which is the y-axis, and y equals 0 is a horizontal asymptote, which is the x-axis. Anybody have a question? Write down whatever you want on these, as little or as much as you want. Anybody need more time? All right, so this one says 4x to the negative 2. Well, 4x to the negative 2 could also be written how? Anybody know? It's not 1 over 4x squared. only the x squared moves to the denominator, so it would also be 4 over x squared. I put both in the calculator here, 4x to the negative 2 and 4 over x squared, and they both made this same graph. I might do this one for you just to show you. This is misleading on the calculator, okay? Because when you graph it, does it look like it touches the x-axis? You don't think so? I'm thinking some of you are going to think it touches the x-axis. If you trace here, look at the y value down at the bottom. Does it ever become exactly 0? Now, if you trace out far enough, eventually to 15 places on the calculator, it will become 0 because that's calculator error. It doesn't actually ever touch, okay, the x-axis. So that can be a little bit misleading for students. All right, so the domain is everything except 0, so we can write it, I guess I'll write it in interval notation this time. Everything up to 0 and 0 or greater, or you can just write x cannot equal 0. Now, what about the range? By the way, this one is going through 1, 4. This is what I call the volcano graph. What about the range, guys? Y values have to be what? It's all above the x-axis, so 0 or greater. Does it have an x or y intercept? No, it never touches either one. So I don't know if you want to write none or just leave them blank, it doesn't matter. All right, increasing and decreasing. One branch is increasing and one is decreasing. Anybody know which one's increasing? The left is increasing, so from the left until you get close to 0. And it doesn't ever equal 0, but that's remember, increasing and decreasing, you don't need square brackets or anything. And decreasing is the whole right branch, so from 0 off to the right, it is decreasing. It's getting closer and closer to 0. Symmetry, anybody? Y-axis, so it is even function. The discontinuity is that x cannot be 0, or it has a discontinuity at x equals 0. The end behavior, this is the one that actually had to do this graph on a end behavior, and most everybody got it wrong. It wasn't on a summative, but what is y getting closer to as x goes forever to the left? As I go further and further left, I'm getting closer and closer to a y value of 0. And as I go to the right, I am also getting closer and closer to a y value of 0. As I go off forever to the left or the right, it's getting closer and closer to 0. Could you get that one right on a quiz? Everybody okay that it's not touching the x-axis, even though it looks like it on your calculator? All right. These are basically just graph analysis. This is a negative x to the negative 5th. Okay, or you could have a negative 1 over x to the 5th. Again, this is misleading, in my opinion, because it looks like it's touching, but it's not. Negative x to the negative 5th, is that what the question was, guys? Okay. Again, very much looks like it touches the x, right? But if we trace over here, definitely tiny numbers, but it's not 0. Okay, even if we were to go out to 10, it's 0.00001 negative in that case, but it's very close. All right, so here I'm just gonna draw. If you put in a 1, if you put in a 1, you'd get out a -1. If you put in a -1, you'd get out a 1. So those are the only nice ordered pairs. All right, domain, left to right, all real numbers except not 0, right? The y-axis is a break or an asymptote here, so it has a discontinuity at x equals 0. The range, bottom to top, very hard to tell from the graph, but it is the same, all real numbers, but y cannot equal 0. So you could write -infinity to 0 together with 0 to infinity. Okay, domain and range could be written like that. Does not cross the x or y axis, even though it looks like it. Decreasing. Any of those decreasing? Look, as I trace here, what's happening? Going up, right? And this one is also increasing. Everybody okay? See that? It's hard to tell, but they're both increasing. So it is increasing from the left to get close to 0, and again from 0 to the right. What kind of symmetry? Origin symmetry, so it is an odd function. All right, what's y getting close to on both the far left and the far right? 0 again? This is all you're going to have to do for one of these on a quiz, guys, is just graph it on your calculator and be able to fill this stuff in and make sure you understand all those concepts still. We spent a lot of time on graph analysis earlier. Okay, couple more. This is important, rational exponents. Okay, does anybody remember how this goes, what it means? If you have like an x to the 2/3, anybody remember? Nobody? It actually means the cubed root of an x squared, or it can mean the cube root of x squared. It doesn't matter which order you do those in. So for this one, with an m and an n, you'd have the nth root of x to the m, or the nth root of x then raised to the m. When n is even, okay, then the domain is restricted to positive values because you can only take a square root or a fourth root of positive numbers. So if it said x to the, 3/4, you'd have the fourth root of x cubed, but because it's a fourth root, x has to be greater than 0, greater than or equal to, is what that's saying. Questions? How many of you remember doing that before, moving those variables around in the powers? All right, so this one says x to the 1/4. So that's really just the 4th root of x, okay? Same thing. You can type x to the 1/4, or you could type the 4th root of x, but it will give you a very small little, if you put a 1 in, you do get out a 1, but then after that, you'd have to go out really far before you hit another nice number. Like the 4th root of 16 is 2. You'd have to be all the way out to 16 before it hit 2. All right, domain is 0 and up, and it does include 0, and the range is 0 and up. You can put a 0 in, and you will get out a 0. Increasing or decreasing, guys? It is increasing, and it is only increasing, actually you don't need a square bracket for that, but from 0, the whole piece of it, it's only defined from 0. Any symmetry for that one? It has no discontinuities. In other words, from when it starts, it doesn't ever end. And as x, we're supposed to start with y, Hofbauer. So as y approaches positive infinity, x, let's see, it's going up on the right, yes, okay. The only other thing you could say, as x approaches 0, going left, y approaches 0. But I'm not going to ask about end behavior of one like that, probably, especially the left end behavior. But it has no negative infinity. Questions? All right. This one is 1/2 x to the 1/5. What would x to the 1/5 be if you were looking at a radical? Anybody know? It'd just be the 5th root, okay? So this would be a 1/2 x to the 5th. It is very tiny. If you put in a 1, you get out a 1/2. If you put in a -1, you get out a -1/2. Oof, I don't know what just happened at the end there. I put in some really big numbers here just to show you that it is getting bigger, but it barely gets bigger. It does eventually hit 2 and stay just above. Okay? And it would take all the way out there before it would hit 2. It doesn't hit it. I shouldn't make my graph. Wouldn't hit it any time on this little window. But it is getting bigger. But it barely goes above 2. But because it is an odd 5th root, you can put any number in, and you will get out any number, even though it looks like it's not going to ever get very big, okay? That would be what's misleading about this one, is it looks like it's not going to get very big, but it does get bigger. You'd have to put in, scientific notation to get out anything very big, but it does go through 0, 0. What about increasing or decreasing? What do you think, guys? Really hard to tell, but is this getting closer to 0, so it's going up ever so slightly, and then it continues to go up ever so slightly, so the whole thing is increasing? It has origin symmetry. It has no discontinuities. And y is getting bigger as, well, let's see. I usually do left side first, so let me write it correctly for you. Y is getting more negative as x gets more negative to the left, and y is getting bigger as x gets bigger on the right. Whoops, that's supposed to be a negative infinity. Just if I put in on the home screen, was it a 1/2, guys? 1/2 x to the 1/5. So 1/2, and then instead of x, if I put a really big number, x to the 1/5. So it is getting bigger. Do you understand what I'm saying? Even though it looks like it doesn't ever get very tall, it does get taller, just very, very slowly. All right. And last little bit here. This is a negative cubed root of x squared. Can anybody tell me how we could write that as an exponent? So if you're going to go put this in your calculator, where's cube root, guys? Y equals, then what? Did it have a negative out front? Yes, it did. Okay, negative is this guy. Then where's cube root? Good morning. Anyone awake? Math. Cube root is right here, number 4. Was a negative cube root, and then there was an x squared in there. Okay, when you square x, it always becomes positive, right? So therefore, when you cube root the positive number, it would be positive. But it does have a negative out front, so it's going to make it negative. So no matter what you put in, these all come out negative. All right, questions? Okay, tell me, somebody can tell me, come on. How would that look if I put negative x to the, what power is that? If I change it, yes, it'd be 2 over 3 to the 2/3 power. All right, and the red and the blue are the same graph. Everybody good? One right over the other. Okay, so if I trace at -1, it is at -1. I think if I trace out to -8, it's at -4. If you just wanted a little bit of 3, 4, 5, 6, 7, 8, it does go down to here. Just to get a little better idea of, whoops, well, it's really bad, sorry. All right, so domain is all real numbers. Range, what's happening with range, guys? Bottom to top. Yep, but bottom to top would be -infinity to 0 with a square bracket. Everybody remember how to do domain and range? All right. X-intercept and Y-intercept, it does cross at 0, 0. What's this left branch doing? The left branch is increasing, so that's from the left until 0 was increasing, and then from 0 to the right, it is decreasing. This again was left, this is right. All right, the symmetry is y-axis. It has no discontinuities, And both ends are approaching what, guys? Yep, it's getting more and more negative, both as x goes left and as x goes right. Was this the last one? Is there one more? Nope, that's it. Okay. So on worksheet 3, you have to do those 5. Be careful, use your notes in case you're confused about something. It says especially number 6.